RollerCoaster Tycoon. I loved playing this game as a kid, on my very first PC and staring at a big buzzing CRT monitor. Devices have come a long way since then, which is why this game can now run on a smartphone. There are a few official RollerCoaster Tycoon apps out there, but this isn't one of them. What you see here is just a website. As such, it works on any modern device with a browser and needs no installation. You open the browser, visit the website, and start playing. In this video, I'll outline how I built this website, show off its current performance, limitations, but also opportunities to make it better. But first, let me be clear that I can't open this website up to the public for you all to play, because that would be one massive copyright infringement. But I hope to change that, and actually think this website would be good business for Atari. For example, imagine providing one free demo level and then offering to buy a license to unlock everything else. People would be only seconds away from trying out RCT and falling in love with it. We could also offer extensions, new rides, new themes, for micropayments, and all that without players having to update an app or something like that. Let's leverage the technological advances of the last 2 decades. I had no success contacting Atari so far, but who knows, maybe with your support this video will reach someone who knows someone, you know? So if you like what you're seeing, please give this video a thumbs up and share it around. So what did I do here and how does it work? On a high level, this is really just a website. You don't need to install anything on your PC, tablet, or smartphone. If you have a fairly modern browser like Firefox, Chrome, Safari, Edge, or many more, this will just work. You open the website, the game loads, that's it. It's also worth noting that once the game is loaded, you no longer need internet to play. Everything is running on your device. I'll dive a bit into implementation details now. So to skip the following slides, jump ahead to minute 5. I did not re-implement RollerCoaster Tycoon by myself here. All of this would not be possible without the amazing open source project OpenRCT2. You can find it on GitHub, link in the description. OpenRCT2 is a C++ re-implementation of the original game, but they also added some really useful features on top of it. YouTubers like Marcel Voss and Cody Watkins also use OpenRCT2 for their videos. Definitely check them out, but chances are, if you're watching this video here, you already know them. So what I did is take OpenRCT2 and compile it to WebAssembly or WASM using another open source project called Emscripten. When you open the website, it will run that WebAssembly in the background in a web worker. The visible user-facing part of the website is just one big canvas element that the game renders to, and that notifies the game about its current size and about user input, like if you touch or click on a certain spot. The game also computes which audio to play, but since web workers can't play audio by themselves, stereo signal is sent to the UI thread about 10 times per second and played from there. There's also a few other interactions between the web worker and UI thread. For example, I made it such that whenever you save a game, it triggers the download of the save game file so you can continue playing somewhere else. Another example would be setting custom cursors, which again can only happen from the foreground thread. So whenever the game wants to change the cursor, the web worker just sends a little bitmap of it to the foreground thread, which applies it to the canvas. Emscripten can even take care of a lot of this plumbing between web worker and UI for you, but some things were broken and there were also some optimizations I wanted to do. So this is probably what I spent most of my time on. For example, whenever a frame is rendered, Emscripten would naively just send it over to the UI thread as a big buffer. But there's a new experimental API that lets you transfer control over a canvas to a so-called off-screen canvas that you can then hand to the web worker. This way it can render directly to the canvas without manually sending around big frame buffers. If you're curious about more technical detail or some of the bugs I had to fix, I'd recommend reading my blog post, link in the description. That post is actually over 4 years old, and back then I did not compile to WebAssembly but to JavaScript, and I did not use a web worker. But most of it still applies, since it is that exact project that I picked up here, now that WebAssembly support is more widespread. In terms of size, the game code compiles to less than 5 megabytes of WebAssembly, compared to about 20 megabytes of JavaScript. For performance, I'm mainly looking at frame rates, which you can see at the top of the screen here. And my findings depended a lot on the device I played on and how busy the scene is that is being rendered. But WebAssembly typically reached between 50 and 100% higher FPS than JavaScript. And of course, running OpenRCT2 natively instead of in the browser is even faster, but I think that barely matters now. The original game ran at 40 FPS, which I can achieve in all but the very busiest parks, so I think I've reached playable performance. By the way, I still compile to JavaScript whenever I need to debug something, and I gotta say, Chrome Developer Tools handles a massive source file like that pretty well. You can set breakpoints, step through code, and all that as if the file was tiny. I think that wasn't the case 4 years ago, so thanks for improving that. Let's talk about how long it takes to load the game when opening the website. Not everyone has gigabit internet, so if your browser hasn't cached most files from a previous round, this can take a minute. However, I also think there's a lot of opportunity to optimize that, which I haven't done so far at all. For example, the majority of resources loaded before the game starts are sounds and music. It's about half a gigabyte, and there's 2 obvious things to improve there. First, all that music is stored as uncompressed waveforms, so using formats like MP3 or AAC instead, that could be compressed down a lot. And the best part is, browsers are natively able to play these formats, so this wouldn't complicate the game logic at all. Second, audio isn't something you need to wait for before starting to play. Worst case, it takes 2 seconds before your favorite ride song plays. And even more so, most music won't have to load at all if you just use a few songs in your park. So I'm convinced that with a bit of work, compression and delayed loading, this game can load into the main menu within 5 seconds or so with average internet. And even then, I don't want to claim that this website would be ready for the masses without a bit more polish. First, the mobile experience isn't great, but I'm currently working on that. The game is clearly optimized for use with a mouse and keyboard. Second, there should be a way to register and sign in so parks and progress can be shared between devices. But signing in would be required anyways if one wanted to sell RCT licenses this way. But the important thing is, there is clear and simple solutions for all that. Technology is ready for this, and I think we deserve it. So before I leave you with some more demo scenes, let me emphasize some of the benefits of making this a browser game. First, as mentioned before, there is no installation required. Not only does this mean you can play within seconds, but also that you can play it on someone else's device, where maybe you can't or don't want to install some big app first. Showing your park to a friend becomes easier than ever. Just send a link. Second, this runs on virtually all platforms and devices out there, so limitations of current RCT products no longer apply. Whatever device you're watching this video on right now probably works. Third, and this is pretty technical, but the game code can actually be simplified when running in the browser. I just mentioned audio. Modern browsers provide APIs to load audio files, process them, and play them, so the C code for that can be removed. Next is graphics processing. I think the game would run faster if it used WebGL or even just the built-in Canvas APIs, rather than manually writing to big pixel buffers. The game also does its own graphics compression, which made sense back when it came out, but I suspect that modern browser-native formats would be better and render faster. By the way, I quite enjoy how browsers let me zoom in and out as I please. It's also worth pointing out that browsers can go into full screen mode, so you don't have to stare at that address bar while you play. I just chose to leave it visible in this video to make a point. So with that, I'll leave you with some more scenes of the game. Please like and subscribe and leave a comment if you have questions or ideas.